Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. In this video, I am going to take up the most important topic of all quantitative aptitude exams. Even at school level, when you appear in Olympiads like IMO, SOF, even the Aryabhat Ganit challenge conducted by CBSE, this concept is really important. The concept relates to finding the day of any given date. This is a concept video in which I am going to take up the entire concept, that is the complete concept with examples. So the next 40 to 45 minutes will change the way you think about this topic, and after watching the complete video and practicing like 30-40 questions, you will be through with the concept and you will develop an amazing speed by which you will be able to find the day of any given date, whether it is in past or in future. So watch the complete video and I'm sure this will help you in cracking all the quant exams. If you have not yet subscribed the channel, please subscribe now by clicking the subscribe button here, and obviously you have to click the bell shaped icon also, otherwise you will miss out on the notifications of all future uploads. If you like the video and at the end of the video you can share it with your friends, and that will be a great help. So let's see the concept in hand first. Finding the day of any date, complete concept with examples. So the first thing you should know when you are taking up this important topic is what are the various types of years. Yes, the years also have types. They are broadly classified as normal years and leap years. Now when I talk about leap years, 80% of the students will say, oh, leap years, 366 days. But there are so many hidden facts which you should know if you want to get the day of any date right. So normal year normally has 365 days, and a leap year has an extra day, that is 366 days. So this is just one of the facts you should know. The normal years are not divisible by 4, and the leap years, they are divisible by 4. Just like the year 2016, 2016. Now 2016 is divisible by 4, so it happens to be a leap year and it will contain 366 days. Likewise, we can take an example here. Say the current year 2024 is a leap year, so 2025. How about this? This is not divisible by 4 and therefore it is a normal year containing 365 days. The ongoing year is a leap year. 2024 is a leap year. Now, apart from this, only 1% of the students know the third fact which I am going to tell you about the types of years. We are talking about the century years. I hope you know what are century years. Century years are the years which are divisible by 100. Just like the year, so I'll take some examples, just like the year 1800, 1900, these are all century years, right? So all century years which are not divisible by 400, they are all normal years. Just like if I take the example of 2100, this is a century year and this century year is not divisible by, say I have written here, not divisible by 4. Here in century years you need to consider the divisor not as 4 but as 400. So 2100 is not divisible by 400 and therefore this is a normal year. All the years, century years, which are divisible by 400, just like, so I'll write the entire concept. Century years divisible by 400. Example, the year 1200 was a leap year because it is divisible by 400. the year 2000 was a leap year, the year 2800 will be a leap year. All these are divisible by 400. So when it comes to century years, you have to check the divisibility of that year by 400. If it is not divisible by 400, just like this, it is normal year, and if it is divisible by 400, then it is a leap year. So this is the first important thing you should know when you are taking up this particular topic. Now come to the second important concept. The concept is that of odd days. Now you will find the term odd days everywhere after this slide, right? So you should know what are odd days, and you should be, you should have a crystal clear concept of odd days. So let's understand what is the concept of odd days. So if I say that there are 13 days, right? So if I say 13 days, this has 1 week, right? That means 7 days plus 6 more days, right? Now, these 6 days are in excess of complete weeks. 1 week is a complete week. We have 6 extra days. So the extra days, when you divide the total number of days by 7, what is the remainder? That is called the odd days. I'll give you one more example. Suppose we are talking about 80 days. Now in 80 days, how many odd days are there? You have to divide 80 by 7. You will get what? 11 times is 77. So 11 weeks and 3 more days. Now these 3 days are odd days in 80 days. So you should know the concept of odd days. How many days are in excess above the complete weeks? That is called odd days. Now we are talking about odd days in years which are other than century years. So other than century years means, let's take 365 days, a normal year. So how many odd days will be there in a normal year? The type of year is normal year. In 365 days, if you divide 365 by 7, so you are going to get 7 5s are 35, so 15 means 7 2s are 14. Now this is the complete number of weeks, and you will have 1 as the remainder. So this 1 as the remainder gives you the odd days in a normal year. So a normal year will have only 1 odd day. Now if we extend this concept to a leap year, we all know that a leap year has 366 days. So if you divide 366 by 7, you will again get 52 complete weeks. But apart from that, you will have 2 as the remainder, and therefore there are 2 odd days in a leap year. So very important concept. If you have to find the day of any date, you should know whether the year which is given to you is a normal year or a leap year. That I told you in the previous slide, and on this slide I told you that in a normal year you have 1 odd day, and in a leap year you have 2 odd days. So another very important concept. Now let's talk about the century years. So here I have written these are odd days in years which are not century years. Okay. Now I will take up the century years. See, this is a very confusing concept. More often than not, the students are committing errors here only, because examiners know that students are not aware of this fact. So other than century years, whichever year is given, a normal year will have 1 odd day and a leap year will have 2 odd days. Now let's talk about the century years. So these are odd days in century years. See, I have taken 100, 200, 300, 400 like this. Okay. What if it is like 500, 600, 700? Why haven't I written that? I'll tell you later. Let me just take up the concept of odd days in century years first. So 100. See, 100 is not divisible by 400. So I told you, whenever we are talking about century years, we have to check the divisibility by 400, not by 4. So 100 is not divisible by 400, and so 100 is not a leap year. Not a leap year. Right? So that is the first thing you should know. Now, in 100 years, how many are normal years and how many are leap years? So if you divide 100 by 4, you will get 25. So it looks like it has 25 leap years because every fourth year is a leap year. But 100 itself is not a leap year, and therefore the number of normal years and the leap years categorization is there will be 24 leap years, not 25. So 24 leap, and the remaining 100 minus 24, 76 normal years. Now this is the first thing you should know, that in 100 years there are 76 normal years and 24 leap years. Now, previous slide I told you a normal year has 1 odd day and a leap year has 2 odd days. So let's calculate how many odd days are there in 100 years. So a normal year has 1 odd day and a leap year has 2 odd days. So in all you will have 76 plus 48, and that is 100, and this is 14 plus 110, 124, right? So 124 odd days. But I told you, whenever you get a number which is more than 7, just divide this by 7 and find the remainder. That will be the total number of odd days. So 124 means 7 ones are 7. So 54, 7 sevens are 49. So this is the quotient, and so we have 5 as the remainder. That means 5 odd days are there in a complete century. That means 100 years has 5 odd days. Now this is an important result, how to find how many odd days are there in 100 years. These are 5 odd days. Now we can work like this and find out how many odd days are there in 200 years. 200 years. So if I have to work this out now, 200 is to be split into normal years and leap years. So how many normal years are there and how many leap years are there? Again you should know that 100 is not a leap year and 200 is also not a leap year because 200 is not divisible by 400. And so if you eliminate 100 and 200, you will have 24 plus 24, 48 leap years, and the remaining 200 minus 48 is 152 normal years. Right? Now if you have to find the odd days in this, you just need to do what I did here. A normal year has 1 odd day and a leap year has 2 odd days. So this multiplied by 1 gives you 152, and this multiplied by 2 gives you 96, and when you add them you will get the total number of odd days, but that cannot be greater than 7, so you have to find the remainder. So what do we get here? 8, 14 means 4 and 2. Now 248, when you divide that by 7, 7 threes are 21, so 38, 7 fives are 35, so remainder will be 3. That means you will get a r equal to 3, remainder equal to 3, and therefore there are 3 odd days in 200 years. So likewise you can keep on filling this table. 300 odd days, if you do the same procedure just like what I did here, 300 is again a not a leap year, so you will be increasing the number of leap years by 24. So in 300 years it will be 72, and then you can find the total number of odd days like this. You will find that 300 years have just 1 odd day, and when it comes to a group of 400, first 400 years, you categorize this and check, you will have 0 odd days. That means in every 400 years you will have 0 odd days. Now again, a very important table. We will be using this everywhere when I tell you the examples based on the concept, right? So this is the concept of odd days in century years. After the years, let's move on to the next concept, that is odd days in each month. This is pretty easy actually. A month either has 31 days just like January, March, either it has 30 days just like April, June, or it might have 29 or 28 days depending on February having 28 or 29 days, leap year or normal year. A normal year will have 28 days in February and a leap year will have 29 days in February. So days in a month can only be these four numbers, right? That's easy concept. Right? Now if you want to find the odd days in any month, just like say January. January has 31 days, right? Now if you divide 31 by 7, what is the remainder? 7 4s are 28, so 3 remainder, and therefore every month that has 31 days will have 3 odd days. Whether it is January or March or May or so on up to December, you can pick up all the months having 31 days, they will always have 3 odd days. How about 30? Just like April. If you talk about April, it has 30 days and 30 divided by 7 will always give you a remainder equal to 2. And so every month that has 30 days will have 2 odd days. Likewise 29, it can only be a leap year February, right? A leap year February will have 29 days. So how many odd days? 7 4s are 28. So if you divide 29 by 7, you will get remainder equal to 1. So that particular month will have 1 odd day. And finally, if it is a normal year, the month of February will have 28 days. So 28 divided by 7 will give you a remainder 0, and therefore a month having 28 days will have 0 odd days. Again, days in a month, you have to check how many days are there in the month, and according to that you have to find out the odd days in that particular month. Okay, so we are very close to the final concept, and then we will be applying all these things to solve problems, and you will see as we progress through the questions, the time taken to get to the day of the week becomes lesser and lesser, and with the practice of 40-50 questions you can actually find that in maybe 20 seconds. And yes, if you can do that in 20 seconds, you know, you'll be one among those 1 out of 100 students who can do that, right? So what are we doing with these odd days? I mean, if you find the total number of odd days in any year up to any date, how is it going to help us in finding the day of the date? According to how many odd days we have calculated, the odd days can only be 0, 1, 2, 3, 4, 5, 6. I hope you know the concept now. And why is it stopping at 6? Because the odd days can never be greater than 6. If it is 7, 7 means 0. Because when you divide 7 by 7, you get the remainder as 0. If it is 8, if you divide 8 by 7, you will get remainder as 1. So number of odd days will be 1. So the number of odd days can never be greater than 6. And that is why we have stopped at 6 here in the table. Now, according to this total number of odd days, we have a table in which we will be telling you the days, not the odd days, but the days of the week. Start with 0, and 0 corresponds to a Sunday. So whenever you get the total number of odd days in the question as 0, that means it is a Sunday. And likewise, now you can move on Sunday to Monday, Monday to Tuesday, Tuesday to Wednesday, Wednesday to Thursday, Thursday to Friday, and Friday to Saturday. So according to how many total number of odd days are there in the date which is given to you, the total number of odd days, according to that you will have the corresponding day of the week. Now let's apply this complete concept to understand how these 4 or 5 concepts help us in getting to the day of the week. So for that, I am taking an example here. 19th February 1744. So watch how to apply the concept. Now that's the most important thing, if you know the concept but you can't apply it, it doesn't make any sense. So let's try and apply it here to find the day of the week for 19th February 1744. Now the first thing is 19th February 1744. This year 1744 is an incomplete year because 1744 is the ongoing year. It is still going on. It is not yet complete. So the first thing you have to check is the complete years. The complete years in this case are 1743, right? Because 1744 year is going on. Now this 1743 complete years have to be divided into 3 parts. First, number of multiples of 400. So 400, 800, 1200, 1600. 1600, that is 400 times 4. So how many multiples of 400 are there? Just separate that out. And then how many centuries? Like beyond 1600 up to 1700 also it is complete, right? So another 100 years. So 1700. These are 100 into 1 time. If it was 1843, it would have been 200. So 100 into 2. And then the remaining number of years, that is 43. So 3 categories of the years. 1600 years which are divisible by 400, and then 1 multiple of 100, and then the remaining years. Now once you categorize this, you have to find out how many odd days are there in these 1600 years, then 100 years, and then 43 years. We have to find the total number of odd days. How do you find total number of odd days in 1600 years? For that, I need to go back to the slide here in which I told you that 400 years have 0 odd days. So every 400 years will have 0 odd days. So 1600 years, just like we have here, will have 0 odd days. Remember, multiples of 400 will always have 0 odd days. So 0, 0, 0, 0 4 times is 0 odd days itself. Now the century years, 100 years. So for that, we'll go back to this slide where we have written 100 years has 5 odd days. So you should remember that every 100 years will only have 5 odd days. So we will write on this slide 5 odd days. So these are the 2 concepts which we have done earlier, and we found out how many odd days are there in 1600 years and then 100 years. Next, so we have 43 years remaining. So we need to find out how many of these 43 years are normal and how many are leap. So if you divide 43 by 4, you get 10 as the quotient. So 10 leap years and the remaining 33 normal years. This is the category you have to make, and obviously you don't have to worry about the century years here because centuries are already separated out. So here you will not have centuries. So just divide this by 4. Whatever quotient you get, they are the number of leap years, and the remaining, the difference gives you the number of normal years. The normal years are to be multiplied by 1 and the leap years are to be multiplied by 2. On the first slide I told you every normal year has 1 odd day and every leap year has 2 odd days. And therefore the total number of odd days here will be 33 plus 20, that is 53. Now consider all the total number of odd days which we have calculated. 0 here, 5 here and 53 here. So the total number of odd days which we have calculated in 1743 complete years is 0 plus 5 plus how many here? 53. But I told you we can't have odd days which are greater than 7. So always whenever you get a number greater than 7, divide it by 7 and retain the remainder. So if you divide 58 by 7, the remainder you get is 7 8s are 56. So remainder is 2. And so you have to remember that in 1743 complete years you have 2 odd days. Now this is the concept of finding the total number of odd days in complete years. So now let's talk about the incomplete year. Now in incomplete year, if you see 19 days of February and January is already done, so January will have 31 days. So in January there are 31 days and in February only 19 days here, 19 days. So we have to check how many odd days are there in these 2 months. For finding the total number of odd days in January, 31 divided by 7 gives you 3. So 3 odd days in January, and in 19 days you will have 19 divided by 7 is you get a quotient of 2. 7 2s are 14. So you have 5 as the remainder here. So 3 plus 5, 8 odd days in the incomplete year. But 8 is again greater than 7. So you have to take 1. R equal to 1. 8 divided by 7 will have a remainder 1. So in the incomplete year you have one more odd day. And therefore what you get here is total odd days are, in the complete years it is 2 and in the incomplete year it is 1. So the total odd days are 3. Now according to this we have to use this concept. So corresponding to the total odd days being 3, we have the day as Wednesday, and therefore for this particular question the day of this date is a Wednesday. Now see how many concepts we have used here, and this is how you need to understand the concept and apply it to solve 30-40 questions, taking some past years, taking some future years, and I'm sure you are going to get a correct answer every time. So let's see one more question of past year. So now I am taking the example of 20th October 1857. Now we all know 1857 is not divisible by 4, so it is not a leap year, right? So let's talk about the complete years first. 1857, the year is going on. So we have 1856 complete years. So I'll write complete years. See, I'm writing all the steps just for your reference so that you don't miss out on anything. But if you have to do it for yourself, you don't have to write all these terms. 1856 complete years are to be divided into 3 parts. So the first part is 1600, multiples of 400. After that 200, because 1600 plus 200 will be 1800, and then the remaining years 56. Now you should know that every multiples of 400 they will have 0 odd days. So 1600 years have 0 odd days. So this is the first thing. Now corresponding to 200 years. So let's move back to the slide where we found out corresponding to 200 years we have 3 odd days. So this is the concept, this is the understanding part, but if you remember it will be great. 5310, right? So for 200 it is 3. So let's move back and write 3 here, and then finally 56 years they have to be split into normal years and leap years. So for 56 years, if you divide this by 4, you get 14 leap years, and the remaining 56 minus 14, 42 normal years. The normal years are to be multiplied by 1, and that gives you 42, and the leap years multiplied by 2 gives you 28. Add them up, you get 70. But I told you, whenever you get the number of odd days greater than 7, divide it by 7 and get the remainder. So 70 is divisible by 7, right? And that means the remainder is 0. So in 56 years, there is no odd day. Now, in the complete years, total odd days becomes 0 plus 3 plus 0, which is a 3. You got to remember this now, because this is the quantity which gives us the number of odd days in 1856 complete years. Now let's go for the incomplete year. 1857 is going on, right? And we are on 20th October. So in the month of January, February, March, April, May, June, July, August, September, October. See, I've written all months. We know that there are 31 days here, and now the important thing is February. So in February, because this is not a leap year, 1857 is not divisible by 4, right? So the month of February will have 28 days, March 31, then 30, then 31, then 30, then 31, then 31, then 30, and then October. What is the date? 20th. So you have to take only 20 days here. And now I will find the odd days. If you divide this by 4, you get 3 remainder. This is 0 remainder. This is 3 remainder, 2 remainder, 3 remainder, 2, 3, 3, 2. And if you divide this by 7, you get 6 remainder. So we get a 6 here. Now if you add all these, you get 3 plus 3, 6 plus 2, 8 plus 3, 11, 13, 16, 19, 21, 27. See, 27 odd days in the incomplete year. That means you have to divide it by 7 again, because you can't have odd days which is greater than 6. If you divide 27 by 7, you will have a remainder of 7 3s are 21, 6. This is the number of odd days in the incomplete year. Now let's calculate. For the complete year it was 3, and for the incomplete year it is 6. So total odd days up to the given date is 3 plus 6, 9. But again it exceeds 6. So you have to divide that by 7 and get the remainder. So remainder equal to 2. And this is the quantity which will give us the day of the date. Corresponding to 0, we have Sunday. 1, Monday. So 2, it means it is a Tuesday. So you can check 20th October 1857 was Tuesday. I hope now you are understanding the concept, and see, you will be gaining speed slowly. So the video will be incomplete if I don't take up an year which is coming up, a future year. So let's have one example in which I will be taking up the year 2189. 6th September 2189. So let's talk about the complete years first. So complete years, how many complete years are there? 2, 1, 8, 8 complete years. So if you have to split it, you have to split it as 2000, because this is divisible by 400, not 4, 400. And then 2000 plus 100 and then 88. See, these are multiples of 400, these are multiples of 100, and then the remaining years. Corresponding to multiples of 400, you always have a 0. Corresponding to 100, we learned in the previous date also that you have 5 odd days. And corresponding to 88, now we need to bifurcate this into 2 parts. Divide this by 4, you get 22 leap years, and 66 normal years. Multiply this by 1, this by 2. You will get 66 plus 44, that is 110. And now if I calculate 110 and 5 plus 0, it gives me 115, but that is greater than 7, so I will divide this by 7. So that will give me a remainder of, so 7 ones are 7, 45 means 7 6 are 42, 3. So remainder is 3. Now this is the quantity I need to remember for the calculation purpose. This is the number of odd days in the complete years, 2188 complete years. So this is a very easy process. If you practice, it is easy. If you don't practice, if you just watch the video, it will be like it's a huge concept. Okay, now come to the incomplete year. So for the incomplete year, the ongoing year, which is 2189 here, we have to reach this date. So January, February, March, April, May, June, July, August and September. 6 September. So this will have 6 days. And now January, 31, February. For that you have to check whether this is a leap year or not. 2189 obviously is not divisible by 4. So it's a normal year. And a normal year will always have 28 days. March 31, April 30, then 31, 30, then 31, 31. Right? So the number of days in each month, and divide each by 7. This will give me 3 remainder, 0 remainder, 3 remainder, 2 remainder, 3 remainder, 2 remainder, 3, 3 and 6. Right? Now add all of them. 3 plus 3 6, plus 2 8, 11, 13, 16, 19, 25. So you have 25 odd days in the incomplete year, and 25 is greater than 7, so divide it by 7 and get the remainder. 7 3s are 21, so 4 remainder. Now this is what I wanted, the number of odd days in the incomplete year. For the complete years it was 3, and for the incomplete year it is 7. So total odd days are, see, you don't have to write anything, this is just for your reference. If you have to do it in the exam, you don't have to write all this stuff. Right, so 3 plus 4, 7 odd days. And I told you, you can't have 7 odd days. 7 divided by 7 gives you a remainder of 0. And whenever you get 0 odd days in the entire date, it means it is a Sunday. You always start with a Sunday if the total number of odd days are 0. So I hope it clarifies all the concepts, how complete years are to be divided into the multiples of 400, and then the remaining years are to be divided into century. These are century years multiplied by something, and then these are the remaining years. So for each you should know how many odd days are there in multiples of 400, how many odd days are there in complete century years, and then how many normal years and leap years are there in these many years. Multiply normal years by 1, leap year by 2, find total number of odd days. If it exceeds 7, divide by 7 and find the remainder. And then take up the incomplete year and go month wise, find all the odd days, add them up. Incomplete and complete years, total number of odd days divided by 7, the remainder will give you the day of the date. So friends, this clarifies the concept of finding the day of any date. I hope the video will go a long way in making you understand how this process works, and it clarifies all the doubts which you might be having. So if you like this video, please share it with all your WhatsApp groups and all other social media platforms, so that all the aspirants will have this important topic clarified, and everybody can take benefit out of this. So thanks for watching this video, and I hope the questions based on these particular concepts will be greatly simplified for all of you. All the best for your practice.